Hello, friends. How's it going? Welcome to this episode of the AI Show. We are coming to you live from somewhere near my basement. I'm excited to be here. My name is Seth Juarez, and we'll be talking about some cool stuff today. I'm super excited. Again, the most important part of the show is I'm adjusting my seat. That's not the most important part, but if you saw me moving around, I feel like my chair was too low, and if I go too low, then you'll think this guy's talking, but he's not. It's just me. All right, so for this episode of the AI Show, again, we're going to go for 2 hours. I'm excited you're here. If you can't be here the whole time, that is okay. We will be sad. But we will get over it because it's Friday. And that's what we have to do. So this week, we have a chock full of amazing guests. We're going to start the first hour in just a little bit with Neta Haiby. We're going to talk about forms and AI. No joke, I have a cool story about this. Maybe I'll tell you when we're doing like the written recap. And then at the top of next hour, Jeffrey Mew from the Visual Studio Code team is going to come on and be like, Seth, you've been using Visual Studio Code completely incorrectly. And so I may get a bit of a scolding. You all can be here to watch for that. I'm pretty excited for that. But again, as always, we're going to have our project that we're working on as well, Rock, Paper, Scissors. We're going to IPO this thing. So I'm pretty excited about that. So yeah, that's what we've got going on. So let me do this. Let me share my screen and Oh man, the background music's like, I feel like I'm in a spa or something. How crazy is that? So let me go here. Let me push this. Wait, which button? This one. Okay. So today, remember I had to, let me turn this on. I had to convince my significant other that this was a necessary work expense. So we're going to use it. Again, number one, we're going to start at the top, probably in the next, I don't know, 5-ish minutes. We're going to talk about AI plus forms. Now, personal story here. I remember this was, I don't know how many years ago, was a relative of mine through marriage. You know, we always say through marriage, when it's like a relative of mine through marriage. It's like the qualifier that absolves you if they're creepy. They're not creepy, but you know what I'm saying? Through marriage. And they employed one person, and their only job was to get stuff out of a form that was printed out into the computer. And this person, that was their only job. And I was like, I don't know if I could live with myself, right? Wow, and the music is super ominous too. I couldn't live with myself. So we're actually going to see what we can do with AI and forms. This is going to be super cool. So make sure you stay in for that. And again, as you know, it's like a live studio audience kind of thing. We're supposed to take these videos out, the chunks of them, and then put them into Channel 9. And so we'll do that. And so you get to see behind the scenes. And Neta has graciously agreed to stay after and answer any questions you might have. And, you know, I'll put them on the screen and everything. All right, number 2, I told you, Jeffrey Mew, we're going to look at VSCode plus PyTorch. And what are some cool tools there? And I was like, Jeffrey, this is actually quite serendipitous. I know, serendipitous. Because we are actually all of us working on a project using, this music is too much for me. I'm on the surprise me. This is okay. Serendipitous, because we are actually working on some code with PyTorch. And he's like, oh, good. And I'm like, can you stay after and maybe help me out where I'm not using it right? And he's like, sure. And so we might get some of that. And then number 3, remember last time we finished off, we got a model working. I'll show you. We'll run the training again. No, we'll run the inference again. But just a little caveat here. I'm going to put this in red here. I uninstalled and reinstalled Conda. So mini Conda is what I installed. Oh, Conde, mini Conda. I'm going to erase that because this is, we have standards here. Mini Conda is new. So things might be broken. And so be nice to me when it comes to that. All right. So that's what we got going on today. Like I said, the most important part of the show, obvi, is all the questions that you have. And so we'll answer them. We've got some pretty cool people here today to do that. And in betwixt all of that fanfare, we're also going to be writing some code. I'm pretty excited. Again, we only do this every other week. So we try to get it all in. Okay. All right. So let me do this. Let me go back to let me bring in Neta. So I'm gonna unmute Neta here. And how's it going, Neta?
Great. How are you, Seth?
Fantastic. So listen, we're gonna. You saw the intro is kind of loosey goosey, but then we got to get all proper because marketing wants us to use this for later too. And so I'm gonna. So Neta and I have worked with each other for a long time now. It's been like what, at least 7 minutes. No, she came on early because she's awesome. But yeah, we've done stuff before, and Form Recognizer is probably like, you know how you're like AI and you're like, oh, we could do cool stuff with AI. Yeah, but it's the useful stuff that matters, and this is probably the most useful AI I've ever seen. Neta, just I'm not trying to Yeah. All right. So let's do this. Let me see. There's comments already before we get on. Oh, it's just welcome. Oh, Microsoft developers here. Hey, everyone. Welcome to the show. Yes. And just put comments on. I'll put them on from time to time, but not during the marketing. If I turn, it's because my computer's over here. Apologies, everybody. Maybe I should put my computer over there so it looks like I'm looking at Neta. It's like poke through. It's there's like a definite barrier here.
Oh, it's other side.
Other side. The other side. All right, Neta. So we got to be serious now, apparently. All right. So the way it's going to work, I'm going to turn this off because we can't have that in the final. So what I'm going to do is I'm going to be like, hello, and welcome to this episode of the AI Show, where we're going to talk all about extracting information from your documents. No, let me do this because I got to do it. I got to do a Twitter video. You know, the one before where it's like, you're not going to want to miss this episode. I'll do that. And then I'll push the button and then the bumper will come on and then we'll do intros. Just for your sake, just look straight at the camera the whole time. If you run out of things to say, just stop talking.
Okay.
Any other instructions that I tell people? It's pretty cash, you know. Let me take this banner off. Okay, no, I'll leave it on for the. No, I'll take it off. I'll leave it on. All right, you ready?
Yes, I am. Are you?
She was all like, Beth, are you gonna be okay? Yeah, I'll be fine. All right, so let me get to this. I got to make sure because the problem is like if I don't do this right, if I don't push this button and then this button it's this one. So this one, then this one, this one, then this one, this one, then this one. Okay. All right, I'm ready. All right, you ready?
Yes, I am.
You're not going to want to miss this episode of the AI Show where Neta Haiby takes us through some of the new things in Form Recognizer. Make sure you tune in. Hello and welcome to this episode of the AI Show. We're looking at extracting information from your documents with new capabilities in Form Recognizer. We've got a special guest with us, Neta. Neta, how you doing, my friend?
Very well. How are you, Seth?
Fantastic. So for those that don't know what Form Recognizer is, can you give them a little introduction?
Yes, of course. Form Recognizer extract information from your documents. It enables you to extract text, tables, selection marks, key value pairs, and any information from a document in various languages.
So, I mean, it's very useful. I've used it before, but obviously it's been a little bit of time for me. Can you tell us what's new?
Yes, of course. Let me show you what's new. That's much better than telling you what's new.
All right, let's pause right there. Let's get your screen ready here.
Here we go.
Edit point. All right. All right. I'll say, all right, let's go to it. You ready?
Yes, I am.
All right, let's do it.
Okay,
hold on. I messed up.
No problem.
Oh my gosh, I'm so bad. That was a good open. Hold on, I got to remove my screen. Gosh, what a noob. All right, here we go. Now we'll go. When we start this screen, just be like, all right, so what you see here? Does that work?
Yes.
All right, let's do it.
Okay, let me show you what's new in Form Recognizer. So we're going to start with a sample labeling tool. This is our sample labeling tool where you can get started easily. And we're going to start with layout. Layout extract the text, the table, the selection marks, and all the information from your documents. And in this release, we added 73 new languages, including Chinese, Japanese, Korean, German, French, Portuguese. So let's see how Form Recognizer performs on these languages.
So before you go there, if I can ask you a question. So is this part of the AI, this thing that you're showing right here? Or is this something else? Because I don't know if everyone has seen this before. So what is this tool you're using?
Yeah, this is our sample labeling tool that enables you to get started. It's hosted in this site, FOTT Preview and FOTT. And it's also an open source. So you can take this tool and customize it and embed it into your end-to-end solution. And you can also easily get started with it to see the results on your documents.
I see. So it's just a tool to help people take advantage of the AI bits, and anyone can take this and use it and put it in their own software even.
That is correct.
Has anyone put this
available as a container that you can deploy on your own, or as an open source, and you can take the code and embed it in your products, or you can use the sample, which is hosted in this link.
Do you know if anyone's actually embedded it in their product already?
Yes, we have several customers who have embedded and created end-to-end solutions and document understanding solutions using this tool, converting it, white labeling it, and putting an end-to-end solution on top of it.
You heard it, folks. There's some code for you to use in your own software. I love it. Sorry, Neta, keep going.
No problem. So let's start with trying it on a document, trying the layout to extract the text, the table, the selection mark. Let's take a document. And I selected this document, which you will see is in Japanese. I cannot read it, but let's run layout on it and see what it extracts. So this document has both English and Japanese on it, and you do not need to specify the language. And when we click the run layout, we're calling the Analyze Layout API in Form Recognizer and sending it the document. You can see that everything that is highlighted is the text that is extracted. You can also see here the checkboxes that are extracted. And if we go to the next pages, because this is a multi-page document, you can see that it also extracts the table. So you can see that it extracts both the Japanese and the English, all the values in the table, all the selection marks in the table, and all the data, including the table structure.
So that's bananas. Like, I'm looking at this before you go, like, you just literally just uploaded this and ran it. Or did you do anything else before to prep it? Or is this just the natural?
Not at all. I just called the Analyze Layout API and sent it this document to analyze. No training, nothing, no prepping. It identifies the language, the selection mark, the tables, the handwritten that you can see here, and all the text that extracted into a structured information that you can use in your workflows.
That's really cool. I'm sorry. I keep interrupting only because this is really cool. And you've kind of worked on this for so long that you don't see, maybe you do, but it's pretty impressive, the stuff that it does.
Totally. This is behind it. There's deep learning machines learnings for the table extraction, for the text. There's our OCR, which is a deep learning OCR that can extract all these languages with high accuracy, both for printed and handwritten. And feel free to ask questions anytime, of course.
Yeah. Yes. And again, I will. So what else? What else are we going to show us? I interrupted you midstream.
No problem. Let me show you how. So when we send the document to the layout analyze, you can see it on the screen what it does, but let's see the output that you get from the API, the JSON output. So the JSON output includes for layout two parts: the read results, which has all the text information in it, the page, the angle, the height of the page. It has for every line the bounding box, the text, and you can see the language character, the Japanese characters, the confidence for it, and also the style for it. So for this case, for example, it identifies if it's printed or handwritten. So this character, this line was printed, so it says other. Let's find here also the handwritten in the document. So you can see that Johnny McCoon was a signature, and it was also handwritten, and the bounding box for it, and the indication that this was handwritten. This is very useful if you have documents with scribbles on them and stuff like that, when you want to identify that somebody had handwritten on it, and you want to move it maybe for human validation or understand that this is handwritten versus printed.
So just to pause right there, because I think, like you say it like all nonchalant, if you write it with your own hand with a pen, it will still pick it up. And
that is correct.
That's really cool. That's really cool. Sorry, I just had to jump in there because, look, I'm a computer vision kind of guy, and the stuff that, I went to school like 10 years ago for this stuff, and this stuff was not all the way possible. So it's really cool to see it.
Totally. Yes. This is very awesome that it extracts all the languages, the handwritten, tells you that it's handwritten. So note it extracts all the information from the document to enable you to put it in your workflow and make decisions based on this data, on this structured data. So awesome. In addition to the read results within the document, which has all the text, the appearance, the bounding box, and information on the text, there's also the page results as part of layout, which extract the tables. So you can see that it finds the tables, tells you the rows, the columns, how many, if there's row span, so if there's merge cells or merge columns, it will tell you the whole structure of the table. And it also refers you to the read results to get the confidence for that text. In addition, let's find the selection marks. So we also extracted the selection marks. So you can see that it also extracts the selection marks, tell you their bounding box and their state, if they're selected or unselected. So you can see that layout now returns all the information from your document, the text, the handwritten, the selection marks, the tables, and it also enables you to extract the data. So if we go back to this document, And let's go to the last page of the document. You can see the document has 2 columns here. It will also extract the data in read order, where it will tell you this is data will be extracted this column first and then this column, so that you can take this data later and do also language understanding and processing on it. Before, we used to extract by order, basic order, which is also available from top to bottom and left to right. Now we added also the ability to extract based on reading order for the first column and then the second column, so you can do language understanding on top of the text that is extracted, and also have the text like a human is reading it in the right reading order.
That's really cool. And I think you said selection like too, because this feature is it's looking at the columns natively, and then the one before was selection. What do you mean by selection?
Oh, selection mark. You see the little selection marks here?
Oh,
so this one is selected and this one is unselected.
Oh, I see.
Let me zoom in so you can see them here. See this selected? So now when you analyze this document, it picks up this is selected and this is not selected.
I get it. So like the little check boxes, because I don't know, when I go to the doctor, right, there's always a medical form here or there where I have to like check, you know, if I did a thing or I don't have a thing, right? And it will pick those up and be able to give you that information as well.
Exactly. And selection mark can look like this. They can be circles that are filled in. There can be just a scribble on top of them. Form recognizer layout will extract all that information to enable you to know what was in the document.
That's cool. So you talked about this. You talked about the columns. Any other things that you wanted to show us?
Yes. Let's go back to that. We were saying layout. Let's go back to our pre-built models. Form recognizer has 4 pre-built models: receipts, business cards, invoices, and we also added IDs. But let's start with the invoices. The invoices enable you to just take an invoice. Let's take this invoice, for example. Same thing, you send the invoice to the new invoice analyze invoices pre-built model, and you run analyze on it. This will extract all the key value pairs, so 26 key value pairs, and also the line items. Now, we added the ability to extract line items. So you can see that it extracts the amount due, the billing address, the customer address, the merchant, and now it also extracts these line items. Let's see them. So you can see that now it extracts also the date, the product code, the description, the unit price, the quantity, the tax, and the amount. And note that when we extract now line items, the labels for the line items will always be the same, regardless how they appear on the invoices, because invoices come from a variety of vendors. Each one looks very different. The structure of the output will always be the same, so you can feed it into your ERP system or your purchasing order system or any other system without the need to figure out which line items belongs to which label in your system.
Holy cow. Like, I did not know this, because these are what are considered the pre-trained forms that are on there. And you're saying that irrespective of the form, it will figure out a unified way to report the line items. Is that what you're saying?
That is totally correct. So we saw this one. Let me show you one that it looks totally different. Let's take this one. And now you can see this one is totally different invoice, different line items, different table structure, different everything. And when you run analyze, you again will get all the 26 field, whatever it finds on the document, and then also the line items.
That's really cool.
Yes, so here, look, we select the line items here, and we got, again, the description, the unit price, the quantity, the unit itself, and the amount.
That's really cool.
Thank you. And note that also all the result will also always be the JSON results you saw before, with the read result, the page results, and also now the document results, which have the key value pairs and the line items information. So you always get all the text, all the automatically detected tables in the document, but now also the key value pairs and the line items from the document.
That's really impressive. Like I said, this is one of the cases of AI being super useful, because we do a lot of transactions over paper. We do a lot of transactions with PDF kinds of forms. This is really useful. Any other things you want to show us?
Yes, of course. We also added an ID model. So let's select an ID now, which supports passports and US driver license. So let's start with the US driver license. Same thing, we call this time we call, if you see here, the API path, we call pre-built ID document, and run analyze sending it this document. And you can take IDs. This one is a nicely picture, but you can take it from photos. You can take it, scan them, send them in any way you want. And you can see that by automatically it extracts the address, the country, the date of birth, the date of expiration, the document number, the first name, the last name, the region, and the sex. And again, you'll get a JSON output with all the information. It also supports worldwide passports. So you can also take a passport, send it to run analysis of the IDs, and it will extract all the information from the passport, the MRZ, which is common on passports, and then within the MRZ, the country, the date of birth, the date of expiration, the document number, the first name, the last name, and the information that is relevant from a passport. It supports worldwide passports, so any language of passports, and USI driver license.
This is cool. And I could see tons of good uses for this, where people just want to have like the identification, like when you go to a doctor's office, for example, and they know, is it really you? And they literally, you can scan it and the computer will be like, yep, that's them. This is really cool. And is this a new model that's come out recently?
This is a new pre-built model that just came out. And we've seen customer using it, especially these days when you want social distancing and you don't want to give your driver license to somebody, stuff like that. You have an app, you take a photo of your driver license or your ID and basically extract the information that feeds into the doctor's office information or any other know your customer information.
This is so cool. This is a lot of new stuff. So we talked about the receipt model that was been there for a while. This is a new model for identification. Any other things?
Yeah, no, we talked about the invoice model, which is also a new model.
Oh, it is a new model.
Yes, we have an invoice, which is for invoices. And we have a receipt, which is for the US sales receipt, the long receipt that you received, and US, India, English receipts that you receive, the one that you receive from stores, from credit slips, from restaurants. That's the receipt model. So the invoice one is for invoices. And it's a new model with the line items too.
I see. So that is new, because I was thinking receipts on that, but invoice is a new model. All right, this is really cool. Any other things? I keep saying, is there any other thing in there? Can't be, but is there?
Yes, there is. There's tons of new things in this release.
Oh my goodness, I'm so excited.
One more thing that I'll show you is Inform Recognize also includes a custom where you can train your model. You can train a model for your documents where you could until now label key value pairs. And let's say I could label address, I could label invoice for, I could label vendor. We added the ability to also label tables. So in addition to the tables that are automatically extracted, let's say this table was automatically extracted by layout, which we saw before, we can now label different semantic tables. So for example, let's say if I want to label this table and just say invoice number, or let's give the table name table 1, I can label a table as a fixed size, that I know that it has only 1 row, or as dynamic, where some of my documents has 2 rows, 3 rows, or 4 rows. I can also label a dynamic table. I label the table, I can give it the column name. So let's say invoice 1, had another column, charges, and another column, total, for example. And let's do row 1 and say, now I can go and label the table. So I can assign fields to each one. So I can assign this to here. I can assign the charges to here, and I can assign the total. Let's assume this was total to here. And I can label like that tables, semantic tables. So for example, if a document has several patients on the same page, you can label this as patient 1, patient 2, patient 3. And label the information to be outputted as a semantic table, regardless if they appear as a table or not on the document.
And that's really cool, because before I didn't know that there was table labeling available. But the cool thing is that you can actually, before you even, because remember you got the specific output in the JSON, but now you can create specific output for tables to match whatever your internal systems can be, so that Form Recognizer responds with something that you're familiar with. Is this what this is for?
That is correct. This is for 2 things. One, if we miss, so if, for example, your table wasn't extracted automatically by layout, and you still want to get it, then you can train a custom model to find your table. So if the table wasn't extracted automatically, you can label it. You can also label parts of a document that don't look like a table, but you want to output them as a table because they're repeated information within the document. So, for example, EOB statement, usually explanation of benefits statement, usually have this part is patient 1, this part is patient 2, and this part is patient 3. And you would want to label this as patient name 1, patient name 2, patient name 3, and the information relevant to them for each one of them. And also, if you want to take these information and put it in a structure that you want.
That's cool. That's cool. So this is a new feature, being able to label tables.
Yes, you can label them. Then you need to go and train, and then you can analyze and extract the information to try it out.
I see. So for clarity, the models that we saw before, there's a bunch of pre-built models, but now there's also the ability to train your own models based upon the forms that you may have and the way that you want to extract data. Am I getting this right?
That is correct. So
cool.
Form Recognizer has the 3 parts. One is the layout that just extract the text, all the information, the table, the selection mark, all the information from your documents. Then we have the pre-built, like the invoices that we just saw, that there is no training required. You just send the documents and we extract all the information for invoices, IDs, pre-built business cards, and receipts. And then we have the custom that enables you to train a model that is specific for your forms to get the data you are interested out of your documents.
I see. That's cool. All right. So any other new things that, like, I don't even know when to stop asking. There's so many new things.
I think that there's more new things that you can see in the what's new. But I think for demoing and stuff like that, these are like the top great features. The language expansion, the tables, the invoices, the IDs are the top features that we can talk about and demo.
That's cool. But I mean, there's so many new things, and I know you have a short amount of time. I don't respect that. Where can people go, unless there's something else you want to show? Where can people go to find out more?
Yeah, you can go to our docs, to the what's new in our docs, to find out more. And you can go to this URL to try it out and play with it with your documents, try the invoices, try the IDs, train a model for your documents. You can do all that in this tool, or everything is available as a REST API. So Form Recognizer is a service, an Azure AI service in cognitive services, and everything is available as a simple REST API call and as an SDK in all the languages that you can easily develop with.
Well, Neta, as always, it's a pleasure hanging out with you. It's a pleasure learning from you. We've been learning all about what's new inside of Form Recognizer. I'm impressed. Make sure you check it out. Neta killing it. That was awesome. All right, are you okay staying around to answer some questions?
Yes, of course. Thank you very much.
All right, so here's some questions. There's a lot of them. Here's someone, Aaron. He's saying, I've used Form Recognizer with custom model. It's extremely easy and works smoothly. You've got a fan.
Oh, great.
Super cool. When I was looking at, because the way you talk about these things, because you work on them for so long, like I'll tell you a story. If you've ever been to a zoo, like there's this place called the Monkey House, and when you go in there, it stinks. But the longer you stay there, the less it smells. Not because the smell has gone away, but because the stink has become part of us. And I'm not saying your product has become stink that's part of you, but you know what I'm saying. And so Jenny's Crew 7 over on Twitch, when you work on something, it becomes a norm. Seth's still mind blown. Yes. And I've seen some of this stuff, but I haven't seen some of this new stuff. So that was cool. Another question here. In multi-selection forms too, it can see if it's detected, but does it detect different check marks in multi-select?
Yes, it does.
Okay. So in tables, we'll find them. Okay.
Yeah, it selects different types of selection marks. They can be scribble, they can be circles, they can be square, they can be just a check mark. This is a deep learning model that knows how to detect all these types of selection marks.
All I can say is, I should have turned that up. Hold on. I'm going to do this joke again. All I'm going to say is, it still feels like it was not loud enough. Question from Sharafuddin. Multi-language such as Arabic text, can it recognize Arabic?
So not yet. We currently have 73 languages. Arabic will come shortly.
Cool. Yeah, it looks like Hussein is saying she mentioned they added 73 languages in the new release. Cool. Here's a question. It's a good question. How much does it cost to, say, analyze 100 invoices?
So the pricing for Form Recognizer is per page. For analyzing invoices, we charge $50 per 1,000 pages.
That's not a lot. Like I was telling people before, like you would have to sit down, and if you had to analyze 1,000 pages and put it into computer.
Totally. So for 100 invoices that were asked, if each one has one page, it will be $5.
Oh, wait a minute. Say that again. So maybe I didn't understand the price. Explain this again. Is that like I went too fast?
So the price is $50 per 1,000 pages. The question was, how much would it be to analyze 100 invoices? So 100 invoices, assuming each invoice has one page, will be $5, if I did the math correctly.
That's like less than your Starbucks drink.
That is less than your Starbucks drink. And think how much it would take you if you did that manually.
Oh my goodness. And like I said, I mean, we must train these things, I'm like, oh, now I'm a part of your team because it's cool software. If I didn't like it, I'd be like, so tell me, you must train this stuff on a lot. You must have good volume of data to train on. Yeah,
our pre-built models are trained on millions and millions of documents to get to high accuracy and the results you're seeing.
That is awesome. Well, Neta, anything else you'd like to add for our fantastic audience that's just chilling with us?
That it was a pleasure being on your show, Seth.
Awesome. Well, thank you for being with us again. It's always a pleasure hanging out with you, Neta. I'm gonna boot you. You okay with that?
Of course. Thank you.
All right. We'll see you next time. All right, friends. That was cool. Right? Hope you liked that. That was really cool. I'm a huge fan of Neta and the work that she does. I'm gonna turn the background music on now because we can. Oh, I need to find a way because my screen's over here, right? And it looks like I'm not looking at my screen. I need to find a way to like move it so that I can go like this. And it looks like I'm looking at my code. I couldn't figure it out. I'm not using OBS, by the way. All right. Top of the hour, we have Jeffrey Mew coming. Let's see if people are talking to me on the tweets. Yeah. Oh, Vanessa's watching. Maybe. Vanessa is one of our producers. She shows up when she wants to. I can say that because she might not be watching. When will receipts be available in Italian? That's a good question. I don't know. We'll have to ask Neta. Wait, Neta's still here. Let me see. Neta. Yes. Someone asked, when will receipts be available in Italian? Do you know that?
Yeah, we do not yet have a date for receipts in Italian, but it's in our roadmap. And feel free to contact us to work with us on that.
Cool. Sorry, I saw you were still there, and that was a good question. Like I said, there's so many languages. How many languages are available in Forms Recognizer?
73 languages.
73.
Including Chinese, Japanese, Korean, and many others.
Do you have like those memorized?
The whole 73? No,
she's like, okay, let's go into we'll start with, would you like it in alphabetical order? That is really smart.
They're all listed in the documents.
All right. Well, sorry. I brought you on just for that question. You're awesome, Neta. Sorry about that. Now really, for realsies, we're going to boot you. All right. So we are going to get back to our projectos. Oh, Vanessa is watching. Dang it. I got to put her on like the back channel, and so you can hear her audibly eye roll. It's fantastic. All right, so we're going to go to our projecto here until Jeffrey Mew shows up, hopefully. Again, for those that are tuning in for the first time, we are working on Roshambo, rock, paper, scissors, because we wanted to make like a social app where people could go and play, rock, paper, scissors against each other. But we were going to start with the computer first, and so we're going to have the computer do it. And so I have a bunch of pictures, and we're building a classifier in PyTorch to help us out. Again, I full disclosure, I rebuilt my Conda environments and I just installed Torch to make sure that it all worked. So if it doesn't work right now, we'll have to be like, oh no, it doesn't work. All right, so let's go there. So Roshambo. Okay, here it is. Code dot. Of course, code opens on the other window. Why wouldn't it? So this is our code. Hopefully everyone can see it. Let's run it to make sure that it works. I think I broke my scorer. Let's try it. I think I broke my score, but let's try it. CDSRC. Kaboop. Okay. Python score. Boop. By the way, my computer is getting really hot. Like I installed the latest version of PyTorch. Oh, there you go. I don't have Onyx runtime. So let's. I forgot to install that. So let's do this. Let's install the Onyx runtime. Install Onyx runtime. By the way, I had an error. Hold on, let me open it because I had an error with the GPU version. Let me move this over here. I want you all to look at my emails. That would be embarrassing. Oh no. Oh no. No. Oh gosh, so many emails. Oh. Ooh. Ooh. It's still loading. Install Onyx runtime. Here we go. Windows with a GPU. See this? I installed it wrong. Make sure I have this English language pack with the blah blah blah. So I'll dismiss this. Here, I'll shut my email down because I think this is what I didn't do. They told me. So I told them like, hey, the Onyx runtime blows up on the thing. So let's see. Visual Studio 2019 rundown. Do I have this? Let's try to make it work. I mean, what? We got time. Let's try to make it work. Yes, I agree. Oh, everything went black for a second, so I had to say yes. It's okay. So how's everybody doing? As this is installing, let me tell you what I'm doing. So basically, scoring for me is when we use the model to make predictions. And the ones that we're going to make predictions on are this one, this handsome devil, for paper, and then for rock, and we want to make sure that it does the right thing. And for us, the outputs are the models, and the best model would be this one. We're trying to use an Onyx model. This is the one that we trained last time. We switched over from MobileNet to ResNet 50, and it seemed to be doing a much better job. So let's go to Reveal in File Explorer. Okay, and these are AI models that we built. They're artisanal free range models. Yay! Yeah. Let's open it up. Okay, so we're opening it in Netron, and you recall, this is what the inside of an AI model looks like. No butterflies or unicorns. It's just a bunch of, literally, look. So these are all convolutional layers. Let me find a regular non-convolutional layer so the matrix doesn't look so crazy. So at the end, there's usually a fully connected layer. There it is. There's two fully connected layers, and just for y'all to see, literally, this is what's inside AI models. How boring. I know. Well, let me look at this. It says my connection's unstable. Everyone see me okay? I'm wired directly into my internet. Maybe my internet stinks. Yeah, this is what's inside of the AI. It's basically a bunch of numbers that we're multiplying pixels by to get an answer out of this softmax layer. And notice for us, there's you'll see the size is interesting. Here, let me zoom it. Boop. So here, let me open the other thing and explain exactly what is going on, because I feel like this stuff is way too. I need to open this in Visual Studio Code. So there is a meta, right? These are the classes. So this corresponds to index 0, index 1, index 2, index 3. And what the output of this model is basically once this comes out, it's going to convert a matrix of 256 to size 4. Then it's going to add this C bias, and then out is going to come this vector of size 4, right? So I didn't want to do that one. Dang it, I did it wrong. So matrix of size 4, and I think, is it shift? Yes. 1. These are so not good. That's why I'm not an artist, friends. And then what's going to happen is in these buckets inside of these buckets there is going to be like some numbers, right? Because at the end of the process, a bunch of matrices are going to multiply the picture, and then there's going to be a density of some kind of number in here, right? And the number that's the biggest, that's the one we guessed. Remember, there was 0, 1, 2, 3, and like you can see over here that if it's mostly in 0, then the answer is none, right? And etc. Okay, is this done yet? No, I'm not going to restart my machine. You crazy. Let's just install the regular Onyx runtime. I can figure out that other thing later here. All right, so go back here. Install the Onyx runtime. Here, how do we do this? PyPy. Oh, there it is. Boop. Let me make sure that which pip. Boop. Okay, it's in the right one, so we'll just go boop. Here we go. Remember, I told you it's a new Conda environment, so that's why it's busted. Now we should say, be able to say Python score. Oh, Python score. And what we will see is hopefully it doing something, but it might break because, again, remember, it's been a while. I think it's going to break. I just remembered something. Yeah. It's trying to connect to something. So we'll do CD, Roshambo, ls, CD data, ls, eval, CD eval, ls. Because remember, what's happening is over here, the scoring file is trying to load up this doc. So let's do a rock, and then let's do a paper here. It's using let's do paper, pupper, and then rock here, and then paper. So what's happening is, look, oh no, paper here. What's happening, and I know I should probably like write better code, but what's happening is it's trying to load this rock from the local host, and the local host for us, there's so many models we have in here, is in the data eval, right? Rock paper. So I'm going to start a fake little Python -m HTTP server, and this should make a server for us. And so if I go to this, check out this beautiful bean footage. There you go. All right, and so now I should be able to go to the scoring, and it should work. Here we go. There you go. Look at this. Let's pretty print it. So it returns a payload, but where's the printing happening? Let's not do this print. Let's just do this. I don't want to do that. JSON.dumps that. How about JSON? How do you pretty print stuff? I remember I did that over here. JSON.dumps indent equals 4. Let's do that. Score JSON. I'm doing like double dumps. If I was 12 years old, I would have made a funny joke right now, but I'm not. So, did I do this wrong? Parentheses number 1, 2, 3, 4. 1, 2, 3. Okay. We'll do this again here. I should probably be smarter about this, but no quiero. All right, so let's make sure this is working. Looks like you are a beginner using PyTorch. We're all beginners with something. I spelled indent wrong like a fool. Indent. Boop. Either way, for those speaking of beginners, if you want to go to pytorch.org, there is a really cool tutorial right here called Learn the Basics. You should totally go through it. It's fantastic. And not just because, you know, Cassie worked on it. Oh, did I do the arrow instead? I meant to do. Oh, I did it again. Dang it. Not just because Cassie worked on it. I used, dang it. Not just because Cassie worked on it, but because there was a bunch of other people that worked on it, like Dimitri. Dang it. I keep doing the arrow. Dimitri. All right, it's really good, actually. I wrote the quick start bit, but everything else is written by all these amazing folks. So if you see me struggling, it's because that's the way real programming looks like. Okay, so notice it printed out. So inference with rock, it predicts rock. Inference with paper, predicts paper. You can even see the density, the relative density of the thing coming out, right? You can see that it's pretty confident about rock here. Now, you shouldn't mistake these numbers for probabilities. They're not, but I guess they could be. What happens is the softmax layer at the bottom forces everything inside of this four position vector. Oops, I should have done the big box. It forces all of these to sum to 1. That's what this does. And so the calculus, when you're doing the back props and the forward runs, are going to force this all to equal to 1. So if you look at the output here, aquí, you're going to see that these all add to 1. But the density is here for this one. The density is here for that one. And so that's what we guess. And that's how that works. Okay. So we've done that. Now the question is, so this works because I remember we added it. Let me close it and open it. See if Visual Studio Code sees it. No, it still doesn't think so. But that's okay. It did resolve it. Maybe Jeffrey can tell us because he's coming up in 10 minutes. Okay. And so notice that what we did last time is we had to load up. We have a model path for outputs. And you can see in outputs, let's just go through this code. In outputs, basically, we load up the metadata and the model itself. So notice this is opening the metadata. It's doing a JSON load, and inside there's the classes. We store those so we know what they are. And then we create an inference section for the Onyx runtime. ORT is what's so lovingly called internally, Onyx runtime. And we're loading up this Onyx model, and this basically just gets the input name for this Onyx model. Ooh. Yeah, thank you. I knew you would be excited. And then this here does some transformations on the image that come in. So this is just loading stuff up in the global thing. And this is what actually does the thing. This actually runs it, right? So when it comes in here, this is just for timing stuff to tell me how long it took to do. And it loads the raw data from the it loads this thing up, raw data, which is just literally like a post, because eventually this will run like using requests or some kind of endpoint thingy. And then what I do is I open the bytes of the image, get all the bits, I munge them into transform that we saved, and then I run the Onyx model, and you can see basically I get the 0, 0 because it's a big matrix, and that's it. And you can see right here that for each of the predictions, oh, someone has a question. If you hear that, that's a question on, and that only happens for Learn TV, by the way. If you're on Learn TV, if you ask a question, you'll hear boom. So for each of the predictions, I just fill it out, and then I do a payload, and then notice that the prediction is literally like the index of the argmax, and that's it. And that's what comes out. So I think maybe we can F5 run this. Why not? I don't need to do this here, but let's do this so you can see it all happening. All the magic can be happening. Okay. Hopefully it works. Here we go. If it doesn't break, then again, Jeffrey can be like, dude, you're using Visual Studio Code. Oh, it's working. So notice in the raw data, you can see it's literally just has image equals. And then so we'll F10. We'll get the image URL out of there. You can see that the image URL is right here. We're going to get the actual response of the image. You can see there's the connection, the blah, blah, blah. This is going to give us the actual bits. Do you see that? Of the picture. It knows what format it's in. And then what we're going to do is we're going to run it through this transform, which resizes it, center crops it, moves it to a tensor, and then normalizes the numbers. And you're probably, well, what the heck does that do? Well, the picture numbers are between 0 and 255. And so normalizing them just changes the range a little bit from 0 to 1. Well, actually, I don't know why these are in there. Those were numbers that I took from a tutorial, but I don't know why they chose these, if I'm being honest. So now once we have it, we do the transformation, and out is a tensor, this tensor that represents the picture itself. And then now we run this prediction through the Onyx session, and there's the return. Notice that it's literally a vector. And that's it. F10, F10. Then we go through each of the classes, and we fill out. This is just for informational thing. You can see that now predictions has all of these in here because we just basically replaced it. There's probably a better way to do this, actually, now that I'm thinking about it, using list comprehensions. But hey. And then we fill this out, and that's the payload. And the payload looks like ESO. And that's it. Don't print it out. There it is for the second time, and there is the answer right there. And I think that's pretty cool, I don't say so myself. So I think for today, once maybe Jeffrey can walk us through how I'm not using Visual Studio Code right after he shows us some PyTorchy things on Visual Studio Code. But that's where we're at. We have a model. We have a model that we've trained. Let me go to the actual training here. This is the training, and it outputs literally this Onyx model. And so now we got to figure out a couple things. Is this model good? How do we make it so that it works on a website? And then later, how do we optimize this so that people can submit pictures, and then we can label them? And then get a whole cycle of end to end. So this is the basic thing. And the other thing is I don't know if I like the way I set this up, if I'm being completely honest. I've been looking at something called a PyTorch Lightning. PyTorch Lightning. PyTorch Lightning, which seems to be a little more programmery. So, and this tutorial they have is actually quite cool. So there is, let me go up to the top. Docs. But yeah, basically what it does is it puts everything into its own class. So PyTorch GitHub. Ooh, there it is. I think I saw, here's it. PyTorch examples. Basic examples. Let's do MNIST because that's easiest. This is super interesting because they basically have this concept of a module that has everything built in, a prepared data in the class. There is a setup, right? There is a training data loader, a validation data loader, and then in here there's a default transfer. No, this isn't the one, but this is cool too. Module. But this is data module. I want to see the training classifier. Wow, that's some rough music. Extra input pipeline classifier. Here it is. This is what I want to show you. So remember how when you can write your own classes with PyTorch? Well, maybe you don't know that. Forward, split batch, training step, validation step, and then configure and then add model specific args. This way of putting it all together in one class is super nice. Whereas right here, you notice that I just have everything everywhere. So maybe we'll try making it work in PyTorch Lightning. And if it doesn't work, I know someone that works there. Maybe we can get them on one of these days. But that's where we're at. The other thing that we did is we started making a website. So there's a lot to do. We started making a website. How do we run the website? I don't even remember. Yarn serve. So let's go cd.docs, cd.ls, client, cd client, ls, and then yarn serve. Yeah, I remember this. So we built a website that's supposed to have this on there. This rock, paper, scissors. We even bought a domain name. I remember. So we have all of this to go on Roshambo. Very good. So docs and then blog. Yeah. So we still have a lot of stuff to do when it comes. Like we probably need to make a logo. Like if we don't make a logo, none of this is real. None of it. So that's that there. But here maybe so we have some options. So let me get my whiteboard out and maybe we can do like a vote on what I should do today. After we have Jeffrey on. But let me see. They're telling me stuff on Teams. Yes, I do. They're like, did you see Jeffrey? He's here. Yes, he's here. Jeffrey is here. So remember, so we have two options here. We got the model working. We can either like clean up our code, clean up PyTorch code, or we can work on the website. So it's up to y'all what we do. I might opt for this one because we'll have Jeffrey here and maybe he can help us, make my code not suck. So we'll do this one. We'll do this one because Jeffrey's going to be here. Okay. Speaking of Jeffrey, what's up, buddy? Oh, I can't hear you. Yeah. Oh, you're on mute. Let me unmute you. There you go. Now you can talk.
Oh, can you hear me now?
Yeah, that was a my bad.
Oh, no worries. Yeah, I was just watching you do your rock, paper, scissors magic, So hopefully you're a better rock, paper, scissors player after this as well.
You know what? I think the cool thing about this, by the way, you're going to hear my kids scream in the background. They're not going to be able to watch the Marvel stuff today if they get yelly. I told them that.
I'm watching that tonight, but yeah.
Oh yeah, you didn't invite me to a watch party, Jeffrey? What?
Oh, okay. Next time. My bad.
I thought we were friends, Jeffrey. Like, what? That's the end of that. Hey, by the way, you remember how I don't know if you don't remember, but Jeffrey, I have like stupid sound effects.
Yeah.
And it used to be hard for me to do, but I put them all onto this handy dandy button thing. So I can literally I'll have to just push a button now. Like I can say like, why did the chicken cross the road to get to the other side?
Why?
To get to the other side.
Oh, I'm slow. It's early in the morning.
It's early, dude. It's like noon. Unless you live somewhere are you in Hawaii?
No. I'm still in Seattle, but
Jeffrey, you're awesome, dude. Let's give him a round of applause.
Yay!
See, I have so many. So Jeffrey, I thought we would do a thing where you take us through some of the cool stuff in Visual Studio Code.
Yeah, for sure.
All right. So what we'll do is this, because they might want to reuse this stuff. the mute. Yeah, I should have unmuted you, Jeffrey. Apologies.
No worries.
Like I said, it's just so let's share your screen and let's see if we can get this going, boss.
It sounds good.
Seth, looks like you're a beginner using PyTorch. Yeah, I'm a beginner at everything. Thank you. Add to stream. Okay, so let's do this because they might want to use this. Should we do a cool library, cool project? Wait, is it cool library, cool projects, or it's going to be cool project? We'll call it project. I need to get a bumper that has tools, like cool tools.
Cool anything. Just like cool blank, and you can always just like reuse it for whatever. Okay.
Yeah. So that's what I'll do. I'll be like, all right. So how do we do this? Because I don't know. We're going to use this later. I'll just do something. All right. This isn't an AI. It's like we're going to do just a little clip. All right. I am super excited to have Jeffrey Mew here from Visual Studio Code team to show us a little bit more about how Visual Studio Code works with PyTorch projects. All right, Jeffrey, how you doing, my friend? Why don't you introduce yourself?
Sure. Hey, everyone. My name is Jeffrey Mew, and I'm a program manager here at Microsoft for the Python data science and AI team within VSCode. And like Seth mentioned, today I'm really excited to show everyone PyTorch development within VSCode.
All right, should we just dive in?
Yeah, for sure. Yeah, PyTorch. First of all, what is PyTorch? Well, if you haven't been listening, you've just tuned in to the stream. It's an open source Python machine learning framework that makes it a lot easier for data scientists and Python developers alike to quickly build and work with machine learning models, like you saw Seth doing earlier. So according to the largest Python annual survey, actually, PyTorch is now one of the fastest growing Python machine learning frameworks. And because of this, we want to make PyTorch development within VS Code a first-class experience. So today I'll just be going through a typical PyTorch machine learning project in VS Code, and I'll be walking you through step-by-step throughout the project, from getting started to getting your data to finally the deployment and training of your models. And alongside, I'll be showcasing all the PyTorch and data science features that VS Code has to offer. Great. So to get started with VS Code, if you don't have it already, you can just download it at code.visualstudio.com. It's like free, open source, and cross-platform, so you can use it anywhere you want. And once you actually have VS Code, you'll need to go to the Extensions tab on the left-hand side here and to download the Python extension. So if you just search for the keyword Python, that's where it is. And that's where all of the PyTorch and data science goodies are going to live. So now that we have everything set up, we can actually get started. So everyone's talking about stocks nowadays. Probably heard people talking about GME. So I've built a simple PyTorch project to try to predict and model the Microsoft stock price. So we'll be using some historic stock prices of Microsoft as their data set. And we'll also be using PyTorch inside of Jupyter Notebooks within VS Code to code up the model and train it. And quick disclaimer, I'm nowhere near a financial expert, so this project just for fun. If it fully worked, of course, I would just be rich right now, but here we are.
The disclaimer is awesome. Past performance cannot predict future prices. But if you do become rich, let us know.
Yes, exactly. This is where it'll all start. This video will make everyone rich, actually.
That's right.
Yeah, so to get started, I already have my PyTorch project already open, as you can see here, and I have a notebook, which I've already pre-coded a lot of the things just for the sake of time. And I'm going to be stepping through the code a bit quickly here, since the focus here is mostly around the tooling. So if you're really interested in the code, feel free to pause the video anytime to look at the code in more detail. So one of the first things, so to get started, one of the first things you usually need to do with any PyTorch project will be to actually import the data set. So here I'm getting my data set from the Yahoo Finance API. And here is actually where I'm actually going to read the CSV and put into this data frame. So I can quickly run the cell with Shift-Enter. And once I actually have my data imported, one of the first things I want to do is to actually look at my data to figure out what the game plan is, what data looks like, what are the columns in the data. And instead of just printing it in kind of a crude snippet or crude format, I can actually use the VS Code's built-in data frame viewer to look at my data in a much more human-readable format. So to do so, I can just open up the Variable Explorer at the top with this button, and I can find the variable I just created called df here, and then click this button on the left, and it'll open up the data viewer on the right-hand side. So you can see this is like an Excel-like interface. It's much more human-readable than just printing it out with a print statement. And here I can look at, what are the things I actually care about in my data set? So for this stock price predictor model, mostly going to be caring about the date, because I need the date to have the relative time of the price. But also I'm going to be using this close column because this is the closing price at the end of the day. And we want to be the that is what the model is going to predict on. So because of this, I know I want to use close and date. I can actually go into my next cell where I just want to say, I only want to select this date and close columns, because like the rest of the columns are just going to be a bit of noise. So to do so, I have this, and I can, again, just run the code by hitting Shift Enter, and that ran that code. And then if I want to see my updated data viewer, I can just click this refresh button on the top right, and you can see now I've selected those two columns. So you can see it's like another sanity check to quickly see that it's actually doing the right values.
I mean, this is really cool. I mean, sorry to interrupt.
Yeah.
This is really cool. I did not know about this.
Yeah.
And I've been using it wrong the whole time. So because I usually just use print, and the data frames print nicely, but being able to scroll through and look at it is a little bit easier.
For sure. Yeah, this is like a lot nicer as well. So another great thing about the data viewer is that you can there's some features where you can quickly filter and sort the values. So I can actually quickly click on the top. So I can sort between like the lowest values and the highest values. And it's like a quick sanity check to see that, oh, there's no like really erroneous data, right? There's no values that are negative, or there's no values that are like in the thousands, even though I wish the price was 1,000 right now.
Yes.
Yes. So now that I have a pretty good understanding of my data set, I also, another common thing you can do is just like have a plot of it just to see a nice trend of it, and another visual indicator as well. But now that I have a pretty good understanding of my data set, it's actually time to pre-process the data. So we want to apply some transformations to the data to better normalize it. And oftentimes you might have like many transformations in a row, and you want to see what happens as like a step-by-step sanity check to see if it actually produces the right values in the end. So this is where like the data viewer comes really handy as well. So I have some code here that will actually pre-process the data. So for example, I'm only going to take the close column now, because that's what we're actually going to be predicting upon. Apply some transformations such as like removing null values and then scaling it as well. So again, I can run the cell by hitting Shift Enter. And then, so I created a new variable here, so I can just open that up as well in this data viewer. And I can see that now all my values are scaled between -1 and 1 as well. So it's another quick sanity check. I can just sort, and now I can see, oh, like I can tell that this function worked.
That's cool.
So now, like Seth had to do earlier, now we need to convert the data to tensors, which is like a machine learning data type that PyTorch understands and works with. So again, I've written another basic function to do this. But again, we can use the data viewer to see if it did it properly. So just go back here, and here is a function which will split it into my testing and training sets. So I can run that again, and I can just quickly go back to my data viewer and see that, oh, I have these four new variables. I can see that they're type tensor, which is perfect because it's exactly what we need. And as well, I see our different variables here, so xtrain and xtest. And again, I can also open up again in the data viewer. So by clicking on the left here, so we support tensors in data viewers now, and we can open that up as well to quickly sanity check our data.
That's cool. Like tensors is really cool.
Yeah,
because you might like all of a sudden it's like Batman in there, you know, na. That's a problem, and being able to see it visually is super helpful.
Mm-hmm.
By the way, I made a Nan joke. Did you like that?
Oh, I honestly missed it, but I will make myself watch this video again just to see it.
Nice, love it.
So one other great thing is you can see the tensor is actually 3-dimensional, and normally we wouldn't be able to render 3-dimensional data, but we actually recently added a feature that's going to come out soon called data slicing. So what that lets you do is if you have a 3-dimensional tensors, which often you will have, whether you have like image data or other data like price data we have now, with data slicing, it actually lets you slice upon your data frames such that you can pick any two-dimensional view or slice of that 3-dimensional data. So if I go back to here, I can quickly slice it, and you'll see that now it's not arrays within arrays anymore. So it's like a lot nicer to view. Cool. Cool. So another common decision, now that we have everything pre-processed, the other common decision you'll have to do is select your model. And there's two different models that I can use to train the stock price predictor. But the two most common ones are called LSTM and GRU-based models. And right now, I'm not really sure which one perform better. So I'm actually going to be running both models to compare their accuracy. But before I do so, there's one other feature I wanted to point out called IntelliSense within VSCode. So if oftentimes, like especially with Torch, PyTorch, there's so many functions and so many APIs, and each have their own whole bunch of parameters, and it's usually pretty hard to keep track of them all. So one great way with IntelliSense is if you type neural net dot, you can see some suggestions for what you actually want to do. For example, if I want to do a ReLU function, I can do this. And then I'll tell you what parameters I need as well. So it's just a really nice way where instead of having to go back and forth between Google to search what the API is, it's just a really nice helper for PyTorch development along the way. But yeah, so now that I have that done, I have coded up a really quick LSTM and GRU model below as well. And oftentimes, especially if you're new to PyTorch, it's pretty hard to see what the model architecture kind of looks like, especially if it's just in code. And if you're taking other people's code on GitHub, you might see the models. It's kind of hard to see what the architecture looks like. So we're going to be using something called TensorBoard to help us with that. And TensorBoard is an open source dashboard companion to help PyTorch and TensorFlow developers kind of visualize aspects of their machine learning models and training. And it's one of the actually more popular tools that's used with PyTorch right now. So throughout my code, I've actually been logging information to TensorBoard log files as I run it, and then which then gets read by the TensorBoard dashboard and parsed into UI components. So one of the actually newest PyTorch features in VS Code is built-in TensorBoard integration. So rather than actually having to run it in a separate terminal window, then launch it in another browser to view it, I can actually launch it directly with VS Code. So to do so, I can just open up the command palette with Control-Shift-P or Command-Shift-P and search for the command launch TensorBoard. And then once you click this, it'll ask you if you want to use your current working directory, which is my project file, and I'm just going to use that. And VS Code's smart enough to automatically find those log files anywhere within them. So I actually have TensorBoard opened up already just beforehand for this demo. But I can see, so I've logged the model architecture, right? So it's a lot easier to see. And you can now, if I want to go to this graphs tab, I can quickly open up this LSTM model that I have here. And now you can actually visualize and see what the model looks like rather than trying to decipher it via code. And trying to kind of like, you don't have to be like Neo in the Matrix, like look through the code. You can actually look at it in a nicer way.
That's really cool. And you sneakily were writing TF events out using the writer. And those TF events is just a file that's somewhere in your directory. How does it know where to find those files? I know you did something like you could choose the current directory but what is it? Does it do anything more than that?
Yeah, so normally when you have to use TensorBoard, if you weren't using TensorBoard in VS Code, you would have to manually, in your command line, when you run the TensorBoard command, when you launch it, you have to manually point to that directory where your log files are in. But what's really great with VS Code is if you just point to any top-level directory, so such as your current working directory, VS Code's smart enough to scour your files or subdirectories underneath to find where that file is automatically. So you don't have to specify that yourself.
That's cool. That's cool.
So now that we have a better understanding of our model architecture, I can actually just run all this code to actually train my model now, or to train the LSTM and GRU models. Again, I've done that ahead of time, so not everyone has to just watch me for like an hour just doing nothing and waiting for the training to be done. And again, to see if the training actually worked and if the models actually converge, we can actually go back to TensorBoard and go into the scalars tab, because that's where I've plotted the loss functions for each of the models, right? And one way to usually know if your model's converging, so if it's by converging, I mean it's like actually essentially finding patterns, is to see if over time that the loss is converging to zero. So we can see both losses are actually going down towards zero. So that's a pretty good sign that they're both actually working in that sense. And then finally, I wrote some code to do some predictions on a test set, because you remember earlier I split it between the training and test sets.
Right.
And I've plotted that as well, just to quickly see. So this is the GRU predictions using the GRU model and the LSTM models. So this is the LSTM one. And you can see the red is the real price over the last few months, and the blue is the predicted one. And you can clearly see that the GRU model way better accurately follows the stock price trend compared to the LSTM one. So we're probably going to be sticking with the GRU model from now on. So it's a pretty good, easy way to test and see the differences between the models. And you can see with TensorBoard on the side, it's really great because I don't have to go back and forth between different applications. I can quickly look at my results, quickly go back in the code, and just make any adjustments I needed. And again,
that's really cool. I mean, and like I said, it's not taking away the flow that people is that. Like, I haven't done the TensorBoard stuff yet. I need to, and maybe you can help me one of these days, show me how to do it in Visual Studio Code. But it's just all just regular standard flow of things that go on when you're building these things, right?
Exactly. And it's very minimal work. Like TensorBoard itself is open source. All I had to do is just add an import, and then anytime I want to save something in TensorBoard, just log it with just one line of code. So it's super basic, super simple, and super easy to use.
That's cool. You got anything else?
Yeah, that was basically it. Now that we see our GRU model is the best one, we can just take that going forward and then deploy it to Azure and have everyone become rich.
Fantastic. Well, Jeffrey, this has been stellar. We've been learning all about how to turbocharge your PyTorch projects using Visual Studio Code. Thanks so much, Jeffrey.
Thanks, Seth.
Jeffrey, that was bananas. That was cool.
Yeah. there's a lot of things you can do with PyTorch right now.
I know. Well, look, how about I'm going to add my stuff to the screen, and maybe do you have a second to answer questions from folks? By the way.
Oh yeah, I can stay for a little bit. I just have to jump to something else afterwards, but right now I can stay for a bit.
Okay, so you just say I got to go and then just jump off.
Okay.
So here's a question, because like, and maybe you can help me out. Maybe like just pretend I don't know anything. He's like, done. So easy. Like, what are some suggestions you have? Because I'm not using notebooks. Should I use notebooks instead when I do this? Or if not, like what are some things in Visual Studio Code that maybe most people don't take advantage of when they're doing this kind of work?
I would say honestly, notebooks are probably the biggest thing people are not taking advantage of. So notebooks are actually like another way, if you're not familiar with Jupyter Notebooks, they're like another way of writing Python code essentially. So rather than having to like use the debugger all the time or having to rerun your file every single time you make a change, if you use notebooks, you can essentially you can think about like Legos, right? They're essentially like building blocks for your code, and you can just test each part, each piece at a time.
So do you see how I just like created a notebook? That was probably the wrong way to do it, right?
Yeah, there should be a command. I don't know if you have the Jupyter extension installed, but if you open up the command palette with Control-Shift-P or Command-Shift-P, and then search create new blank Jupyter notebook.
New Jupyter.
Oh, yeah, you see it right there. Create new blank Jupyter or blank notebook. Yeah.
Here.
And then this is what launches in our notebook editor.
I see. But right now, if I want to use, let's just say I want to use this Conda environment here. So let me, so I don't need this. Let's quit that here. Let's quit that here. Okay. So this is going to be super helpful. Cool. Okay. So now I'm in here. I'm in the right, this, by the way, just for your information, this tells me the current Conda environment I'm in, and this tells me like GitHub stuff is. And so I'm in the, I need to make sure I have IPY kernel installed in this environment, right? So
what's also great is you can install it this way, but VSCode will automatically, when you actually try to run try to launch a kernel there, it will automatically detect
what
IPY kernel, and if you don't have it installed, it will do it for you.
Will it respect my path too? My
torch? It should, as long as the kernel in the notebook is pointing towards that environment, like that environment kernel.
Well, let's try it. Okay. So I can Control S this because we're done with that. Okay, let me just close everything. I'm just going to declare window bankruptcy.
Okay.
Boom. Okay. So now I'm here in the source. I need to Control-Shift-P, create new blank notebook, and then Jupyter server. No, not started. I put it to the Torch environment, right?
Right.
Which is the right one.
And then you'll see at the bottom right, it says, you need IPy kernel, and then you click install, and it should hopefully install it for you. So you can see it's like a way better, or way nicer getting started experience for notebooks, rather than having to do everything through command line, having to know what dependencies you need to install for it, and then just manually pip installing everything. It's just like all in one integrated. Yeah.
This is cool because like, I didn't plan this, by the way. I just literally was like, I declared Conda environment bankruptcy on Thursday, and just like literally uninstalled and moved all my Conda environments out of the .conda thing. And so this wasn't planned, but this is cool because I had never done it this way. Because I usually do like pip install like all of Jupyter, but you don't necessarily need all of Jupyter, right?
Exactly, right.
And this is a much better way to do it. Okay. See? I'm already getting smarter. Hold on, there's people saying stuff. Let's see what they said. Oh yeah, check out Jeffrey's blog here. Make sure to do that. Also, Mike on Lineable says this looks good. Like Mike and I would probably hang out and just be like super vibe and just be like, Mike, that's awesome, and he'd be like, looks good. And we don't have to say anything else to each other. Anything. That's all we need. That's cool. Also, here's Mihailo. Hello. Can someone buy me a Surface Studio? Yeah, somebody definitely can.
Maybe you can use the stock price prediction to invest.
Yeah. Jeffrey, like, yeah, it's like, yeah, I'm going to give you a clap for that one because that's really good. Thank you, Jeffrey, for that fabulous Okay. So yes, someone indeed can. Amazing. Okay, so I'm wondering if Sri Shragiri is saying that this is amazing, guys, or amazing guys, like me and you.
I thought it was the latter, but I would
Yeah,
also
I did
take
too.
the compliment.
I did too,
Personal.
Jeffrey. I'm just gonna take it as a compliment
Yeah.
and just be like,
I can tell you're really having fun with those
I
sound
know,
bites.
I know. It's the button. I have one. Let's see, what else do I got? Like, I have another one. Like, if something's really exciting.
I was like half worried you'd just be like spamming those buttons while I was talking to you.
I was filling time while I was installing. Okay, Jeffrey. Gosh. All right. So I have PyTorch installed, and like I just say, I don't know. Oh, and I need to save it too. Control S. Let me save this. Save it into my. Let me just make a notebooks folder. Notebooks. Boom, and then we'll just call this one, because what we're doing is we're refactoring. So we'll just call this refactor. Do you have any naming conventions you do with this stuff?
I feel like notebooks right now is like, I guess one of the pros of notebooks is that it's so flexible, so that there's just like no convention, like there's not too many best practices for notebooks right now. It's like the beauty of notebooks is so flexible that there's really no wrong way to do a lot of things.
Oh, and it remembered the right one, or
right.
did it?
Yeah. So that's the thing with notebooks and VS Code is we will save whichever content environment.
Oh my goodness. I've been doing this wrong. I can't, even with myself. Jeffrey, where have you been all of my life? Let's go.
Next time we'll watch the Marvel and we'll do some VS Code
yes,
stuff.
Yes. I like kettle corn, incidentally. Okay. If you're buying. Okay, I mean, I don't want to put you out or anything. So let's see. For Torch, let's just do this here. Let's just try something. What should I try here to show people? Okay. Let me do my data sets here. My training data set.
Yeah.
Boom. I need to shift this over. And the data dir for us is going to be data dir. I need to tell her where that is. So data dir equals boop, dot.
You can see that's like another pro of Jupyter Notebooks, where like, oh, you made a mistake, so you can just quickly edit that individual cell. You don't have to rerun the entire Python file, or you don't have to have a debugging session to quickly update that fix.
So we're going to go to data here. I think this is the right way to do it, and this should work. Data loader is not defined.
I need to import that, or
aquí está. Data loader. Like, do you like? I consider myself like a, like a programmer type, but I don't know if I'm like the best, Python guy. Anything I'm doing wrong here that you're just like, you should totally not do that?
No worries. I think you're just as good, especially with that learn the basics blog.
I know. Do you like that flex? It was a mini flex. Yeah. So this is working. So like, if I go here, this shows the variables. Right. I don't know if it does anything, but here's for example, some classes. Oh, pandas.
So there's some requirements. Like the first time you do it, you'll probably have to install a bunch of stuff.
That's okay.
But as you saw in my video, once you have everything installed, everything's just very seamless and working really quick.
No, this is actually cool. I want people to see this. This is cool.
One feature I want to point out before I have to leave soon was there's this extension that's works in conjunction with notebooks called Gather, and it's also open source as well. So if you go in the extensions tab and just look for the keyword Gather, like Gather, there's this really cool feature. So for notebooks, oftentimes one of the pros of notebooks is that it's so flexible. You can write code anywhere, right? But the con of notebooks is because you have so much flexibility, it could be like kind of messy, right? There's going to be like code all over the place and might be not in order as well. So the thing with Gather is it actually is smart enough. So let's say you write a bunch of code and the last cell you have in your notebook is about how to generate like the actual code to train the rock, paper, scissors model, right?
Yeah.
Let's say you only want all the code that is required to generate that like the code in that cell, which is to generate the rock paper scissors model, you can run gather on that cell, and it will gather all the previous cells, like only the cells that are required to generate this cell, and only the code that is required. So if you have a lot of print statements, or if you have a lot of plots which aren't required to generate that, then they'll automatically do that for you. So that's another cool thing.
Jeffrey, by the way, Psychobeat, try Alt F4. It will give you money. Like if me and Psychobeat were like hanging out, you know, at a restaurant or something, he would get the spiciest food. You know? Yeah. This is cool. So I installed this gather. Very good. Now you're saying that like mine is an imaging thing. So maybe what I need to do is, I don't know, train data set, train data load. Let me pull out some tensor data here.
Okay.
So let's go to train here, and let me remind myself. You know when you write code like 50 years ago and you're like, I don't remember what I did. What is happening? Oh, I know where to look. So I want to get something out of a data loader. So let's do this. I know what I'll do. No, I don't want to do that. Okay, let's do this.
If you just started all your coding in a notebook, you wouldn't have all these problems.
Yeah, I mean, I feel like you're calling me out, but you're right? A train data loader, and I think I can say 0.
What's also really great is once you're done with your notebook, you can actually run gather and a combination of gather and if you see the top button right beside the save in the toolbar, like 2 to the right of the variable explorer, one more to the right. Yeah, you can export to different things. So you can export to a Python script, so it'll just automatically convert it all to a Python script as well. So you kind of get the best of both worlds with a notebook, where you get to iterate really quickly, and also like having all the things like the kernels and all the variable explorer features. But then at the end, you can jump back to a Python file if you're more familiar with that.
That's really cool. So let's do this. Let's go to the data set, because I think in the data set, I'll be able to get a tensor out and try that other thing out. So let's train data set. Nice. I wonder if I can get a 0 element out of there. There you go. And what I'm going to do is I'm going to say item equals, and then I'll get the first one, because I think the first one's a tensor, and it's in a... and now I should be able to go here and do this. What? But this is like inside of this, there's like another tensor, basically, right?
So like I mentioned before, some of the data slicing stuff that I showed earlier, where you can view 3D, like 2D slices of 3-dimensional tensors, that's still in the works. So that's actually going to hopefully come out next month. So that's why you're not seeing it right now. It's like on a preview build, special privileges, I guess. But that's something to stay. Yeah, that's something to look out for.
And the reality is that I don't have special privileges. Duh. All right. But this is cool. Like right away, I'm seeing that the refactor, if I do it all in notebooks and then do a gather on the final thing, then I can put it into a format that how's the gather? Oh, the gather, is this the gather thing? What's the gather thing?
So the gather, you see the icon to the right, like it has 4 icons in each of the cells at the top, like the run.
Yes.
Gather. So if you run that, but it has to be done on a cell that's already been executed, and there might be some things you have to do the first time, so you might have to like restart the kernel, etc., because you just installed gather. But if you have it already installed and everything, if you just click that button, it'll just gather all the code that is required to generate it.
Right. If it breaks, he already told us why. Please run.
If you've just installed the extension, I think you need to like restart the kernel. Is like one of the things, or close your opener notebooks. Yeah, okay. It's just like an install thing, but yeah.
You don't have to apologize. We already love this, Jeffrey. I feel like you're like, my baby's acting up, and I need to tell you why. I mean, just woke up. You literally just put it on. All right. Oh, I do that sometimes. Is it better? Do you have to right click and say open as notebook? Open a notebook editor, right? Oh, look at this.
That's the feature I was talking about. Yeah.
What does that do?
So I believe it just runs the same command I told you at the top, right? Where you actually can convert it to a Python script. So I think it'll just do that ahead of time for you, so you don't have to open it and then click it again.
Got it. All right. So let's right click, open in Notebook Editor. Let's try it. It still remembers. Look at that. Still is like knows. I've been doing this. Like, I'm not even joking. I've been doing this wrong. Like, I feel like I've been installing way too many things, and it's just, you know, I'm incorrigible.
We know Conda is like one of the most popular environments for data scientists as well, which is why we want to have like Conda like make Conda a really good experience with VS Code and notebooks.
That's cool. So let's do this. Something's happening. Something's happening.
Doing a bunch of magic in the back end.
Oh, and then I can just go like, oh, make this a Python script.
Right.
Oh, what happened? What did I do wrong?
There might be some. There might be. You might have to install some dependencies which didn't get installed. So I see the error already, but yeah, it should work.
This is me again. I declared Conda bankruptcy.
Mm-hmm. Yeah, probably. Let's just blame Conda for this one. Okay.
Yeah. It definitely wasn't. It wasn't your baby.
But yeah, you can see how this is like this workflow is extremely powerful.
Just let it sit there, Jeffrey.
Okay.
No, I'm just kidding. Yeah, I didn't install Jupyter, and that makes sense.
Yeah.
But this is cool. And then, yeah, I see. Because then it's exactly the same. But if I put like some other code in there, it doesn't matter. It's just not, it doesn't matter.
Yeah.
Okay. Cool. Well, this is cool, Jeffrey. You're the best. Anything else that I should look at before you go?
That was mostly if you want to like keep track of all the features that are coming up. If you just Google Python Visual Studio Code blog, you'll find all the information about our blog where we post the latest updates. Or if you want to look at our Twitter as well, that's when we post all the latest updates. So if you want to get all of the latest features ASAP, then that's where you can check it out.
Python Visual Studio Code blog.
And I think it's also in the AKMS links that were posted as well. But yeah.
Look at this. Like, I love when we name things like super cool. Wow, what color theme is she using?
Oh yeah, I don't know exactly which one this is, but I always thought this one was pretty cool too.
What? We need to talk to Luciana
on the show. Yeah.
Luciana, help us out. I got this stuff. And then like yeah. Like, I don't know how to change the font and stuff for this. Is there like, do you know any of this? How to do that?
I'm not too sure. There should be some settings in the VS Code, but off the top of my head, I don't know right now because that's not something I normally do. But yeah.
No problem. Jeffrey, you have been a star. Thanks so much for helping us out, bud.
For sure. Thanks so much for having me. Yeah,
we'll see you next time. Oh, I like totally kicked him out too soon. I feel bad now. I'll just put this on. I have sad music on because now that Jeffrey is gone, we're going to have to figure this out on our own. That's okay. We can do it. All right, so let's do this. I think I want to refactor this. We've got like, I don't know, 25 minutes. What can we do to refactor this and make this more intelligible? Because I want to try a couple of things. And then what I'm going to do is I'm going to try to run a bunch of different models until we get the right one. Because right now we try to ResNet 50, but I wonder if we can get something smaller than that. Control Z, let's see. Models dot SenseNet. They're all new. I've never heard of this. These are new. Platform aware neural architecture search for mobile. Let's see. Here's our ResNets. We got a ResNet 18, ResNet 34. Let's try a ResNet 18 because I want to make something smaller because eventually this thing needs to run in our browser. And I want to switch things around, but again, I'm so scatterbrained. Let's do this. I'm going to try to refactor into something that's a little nicer, that has its own class, and that you can pass in the bottom layer. But then that would be tough, because how would we export? How would we export it, right? All right, let's just try running this, and then we'll go from there. Resident 18, cd ... train. By the way, I will tell you that this crashed my computer a couple times yesterday because I was having memory issues with the way it was running. Hopefully I won't have that now. cdsrc python train. And let's do this. Let's clear out all of the outputs. So no, reveal and explore. Oh, it came all the way over there, huh? That was weird. I think let me just take some of these, all of these. Hold on, let me see where it's at. It's already learning, so it probably did the model meta. So we'll just put these on my desktop for now. New folder. Where did that folder go? Oh, I know where it went. It went into show desktop items. There it is. Don't you love it when your computer just gets so slow? It's doing this. Oh man, there you go. The reason why is it's doing this right now. Oh wow, that's kind of a huge jump, right, between train and validation. Enforce failed. What? Yeah, there's something wrong with my computer. A fail here. But this model that we were building, it seems to be better in the sense that here it's smaller. Yeah, look at that. Way smaller. That's cool. So maybe we should do a Resident 18 because it's smaller. Let me see what's going on with my machine. It's telling me I'm running out of space. This PC. Oh my goodness, I am running out of space. Oh my gosh. I'm gonna need to move some files. I have like 6 gigs left on my hard drive. This is what happens when I get the cheap. How many? I only have 500 gigabytes on this hard drive. I need to do something. That's a oof. Okay. So let's refactor here. Let me close some things down. And what we'll do is I can close this here. We don't need this anymore. I'll leave this open. What I can do is let's try to refactor this whole thing into something a little nicer using PyTorch Lightning. So let's do that. Let's learn it together. I've never done this before. PyTorch Lightning, because I want my code to be so readable. So readable. So let's go to the docs here. Lightning in 2 steps. Keep all the flexibility. Install or with conduct. You can also conda. Should we? I wonder. Is it better to install it with pip or conda? I don't know. Let's do conda install. No, let's do pip install. Just make sure it's the right one. Which pip? It should say, you should see torch here. Make sure it's in the right one. Pip install PyTorch Lightning. There you go. We have done the first piece of instructions. Import the following. I don't want that data set. We're going to do ours. So we'll do that. So we'll do this. We'll leave that over there. Here. Go down. You keep doing what you're doing, buddy. Oh, derf. It's not there yet. So we'll just wait for that. Check in themes and color settings. Oh yeah, you're talking about for this thing. Yeah, I think you're right. I think you're right. So we'll wait for that. I don't think we need this data set because I have the thing I want to use. Right, I have my data set, and it's going to be an image folder data set. I haven't seen this random split, so maybe I can just, instead of having train and eval, I can have everything in literally one place for training. Okay, so now we can do this. There it is. Happiness. Okay, so we did that. Scroll down. So there is this thing called a lightning module. Looks like lightning module. A lightning module defines a system, not a model. Okay, so let's go look at a lightning module. Computations in it, train, validation, test, optimizers. Okay. Notice everything is the same code. The PyTorch code is not abstracted, just organized. There are no CUDA or .2 calls. Lightning does these for you. There are no samplers for distributed. Lightning also does this for you. Nice. A Lightning module is a Torch NN module, but with added functionality. Use it as such. Okay, so what is in there? So there's methods for configure call. I'm trying to see whether, okay. So it looks like there's a training step. So let's make one. Let's make our Roshambo Resonant 18. So let's go back here, and we're just going to make our class here. I'm just going to copy it and fix it. Okay, here we go. Fantastic. So for this one, we're just going to call this one a Roshambo ResNet 18 lightning model. I don't think we need a latent dimension because we're not doing that. We don't need encoders. This is not what we need. Let's look at this code here. Shared a step. What does that even mean? Functional MSC loss configure optimizer. Okay. Shared self.log, validation loss. Loss, a training step, shared step. Oh, I see. So what they did is it's the same step for them. That makes sense. And that's going to be the same for us. I see what they did. So the training, we did something similar, but it's just organized in a really dumb way. Let me show you what I'm seeing. Because I feel like a lot of things just happen in my head that didn't happen in yours. I'll show you what happens. So for us, notice that for every batch, we run the same thing. Do you see that? Literally the same thing. For every epoch, we just run over every single batch, right? You can see that I do the to device, and then I say, let's do the batch, right? And then I return the thing. And then that's it. And notice that for them, what they're doing is, let's take this out because this is confusing everybody. There is an init, which initializes anything. There's a training step. There's a validation step, just like I have. And then they put it into a shared step, which to us would literally be this like batch code. So let's just, I don't know. Let's just do it. Hold on, let me see how they do it. Functional MSE loss. Oh, see, what we do is we encode the loss here. That's cool. But for us, the loss comes from this thing over here. You can see that the cost function's in there. You can see that the main one is here. And then finally, you can see the loss is literally this thing. And then cross entropy loss. Okay, so let's do it. Let's go ahead and define our model. And we'll take our model and just do like the NN sequential. We'll just do that for laziness sakes. Boop. Boop. Like so. That right there. Our loss function is going to take this batch and return the loss. Our validation function is going to log the validation loss. It looks like there's a shared step, and this will be our batch. Okay, our batch will have the X and the Y. So if we go over here, you can see our batch function. Wow, this is really getting rid of a lot of code for us. So for our batch, notice that this is an epoch, but this is our single batch. Let me just take the code, and then we'll fix it. Look at that. Look at that. We're gonna get that. We're gonna do that. And I don't even need to do all this other stuff, like enabled stuff. So let's do this here. And in our refactor, our shared step is going to look like this. Okay. So I don't need to do this anymore because I think the optimizer is there already. Let's Control Shift here. Wow. So this is all like not even. Oh, crud. I need to reformat this. Oh, this is good. This might not be good. Yeah, that's not good. Boom, 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 boom. So, question from Jershawn. Just tuning in, what is he using to customize his PowerShell outputs with different colors like that? Hanselman did a post on it. I can find it for you. But basically, it makes it really nice because I can see what conda environment I'm in. I can see what directory I'm in, and then I can see what's going on GitHub-wise. It's super nice. Thanks for seeing that. We're gonna take this out. Okay. Then this is the shared step. Okay. Hopefully it takes care of okay. Let's go back to the codes. I want to make sure that I'm doing this right. Self.encoder. So for us, it'd be self.model. So self.model equals that. Outputs is going to be, okay, so we have the shared step. You remember that they had X, blah, batch. We need to get the X and the Y from the batch. So we'll say X, Y equals batch to dethrone it. Predictions are there. The cost function is there. I wonder, like, is it doing the oh, I think it hides that in there. You see, because it's not you can see that it's not doing any of that other stuff at all. Like the optimization bits, it's not doing that. So maybe just need to put it in here. So I don't need to do anything. Wow, I don't need to do anything. I just need to return the loss. You got to be kidding me. Loss. Oh, geez. Wrong place. We were over here. My bad. My bad. So I don't need to do anything with this. I don't need to do anything with this. I just need to return NN dot. How did they do this functional? I just need to do a cross entropy loss. NN functional MSE loss. Oh, and from torch in import NN. Did I do that? Yeah. So NN dot functional function dot. Let's see what we got. the wrong one, but I mean, I see. And PyTorch Lightning probably does the dot cross. Oh, geez, I need to go figure this out here. Torch.nn. Oh, I got to turn the music on. Sorry. It's been weird. Awkward. Torch. By the way, we got 8 minutes left. Here we go. Torch.nn. And then we need to get the functional stuff here. So nn.functional, and we want cross entropy loss. nn functional, functions, containers, non-activations. We want loss functions. Here we go. Loss. We want cross entropy loss. Yeah, but I mean, I want to do it the way they're doing it, right? They have a way that they're not using the class, right? They're using the actual. Yeah, see how they're doing it, but that's not how they're doing it here. It's you see how they're doing this? nn.functional.mse loss. So torch.nn. Let's go to their actual torch.nn. .functional. Torch.nn.init. Torch.nn. Oh, there it is. I saw it. Torch.nn.functional. There we go. And we want loss functions, and we want binary cross entropy. Let me make sure that that's the one that I'm using. I'm pretty sure it's binary cross entropy loss. No, it's just cross entropy loss. Cross entropy loss. Cross entropy. That's the one. Maybe we should be using binary cross entropy. I don't know. Binary cross entropy with logit cross entropy. Cross entropy. Log max NL. Okay. Cross entropy. So when we do this in our spot, we are basically doing this, and we're going to do outputs and then Y. And then all of this we don't need. And then, yeah, that's it. We're not using Atom. We're using just standard SGD. Self.parameters. Our learning rate starts at 0.01, and then we do back off. So we'll have to figure out how to do that. Okay, so this is what our thing should look like in PyTorch Lightning. It seems happy. Wow, this is if this works, this is way better than all of this junk, if I'm being honest. Oh, but then we needed transformations. Yeah, I think there's more in there that we're not getting. So let's go back to their docs. And what I'll do is that we have a couple of minutes here because I want to make sure to tell everyone what's coming up next time. I'll tell you right now. Coming up next week, we have Saudia Das talking about running Azure Machine Learning anywhere. So make sure you turn into that. Let me put it on there so you can see it. Run Azure Machine Learning from anywhere. But this is cool. I might spend some extra time getting this to work, just for me, and then go through what I did. Although it's kind of cool, to hang out and work on it together. But there's a couple of things missing, I think. The first is we're definitely missing transforms. Transforms. The other thing we're missing is LR backoff. This is learning rate backoff. We're definitely missing that. And then there's some questions I have about like model saving plus loading. That's it, I think. I mean, I feel like this is actually really quite cool how this is doing it. And there's like built-in log and stuff. And this, I mean, yeah, if it's this easy, let's go back to this Lightning module and let's go to the methods. Configure callbacks. Oh, wow. Model checkpointing. Oh, my goodness. There's a lot of stuff that I'm just not doing well. There's a freeze. Freeze all parameters for inference. Oh, my goodness. This is cool. Save hyperparameters. Oh, wow. So there's a training step. There's a step end, and an epoch end. To Onyx. Oh, my goodness. Oh my goodness, this is so cool. Lightning module. Validation. So I wonder about the data though, because remember there was data modules too that we saw. So let's go GitHub, PyTorch, Lightning. Remember we saw the thing that we made a mistake and I thought it was like, here's some Peel examples. Basic examples. Data module. Lightning data module. I see. Okay. So we're going to need a data module too. Okay, this is cool. I love, like, look, I'll be honest, and we've got like 2 minutes left, so I'll just stop here just to tell you that basically what I'm going to do is I'm going to try to put this into a PyTorch Lightning module. And then once we get the code working and repeatable, then we're going to try to move it into the cloud so that my machine doesn't break. As you can see, we're going to run into limitations of my computer. Wah, wah. Yeah. My computer fell asleep, by the way. Wah, wah. We're going to run into limitations of my computer. Kind of a bummer. And so we'll move all this computation to the cloud. But yeah, I'm pretty excited. I'll do some more research on this to see if I can get a data module together with a PyTorch Lightning regular module, and then it'll be great. So what I'm going to do just to finish up is remind you that we have a cool episode coming up next in 2 weeks, I think. Run Azure Machine Learning from anywhere with Saudi Adas, and I am going to leave you with that. Thank you so much for coming. Hopefully, we will see you next time, my friends. It's been another episode of the AI Show Live. Take care.